Hello engineers, welcome to fourth lecture of ASME BPVC section 2 code training. Today we will discuss about subpart 1 in part D guys. Okay, I already explained everything in detail in last lecture about the structure of part D. That is about how many subparts are there in part D and what do you find in mandatory and non-mandatory appendix and what do you find in each subpart. So I already given basic understanding, basic details about the structure of part D. So if you didn't watch that video, it is about 2 3 minutes only guys. Okay, first watch that video and then watch this video. Then only you will get some idea. Okay, let's begin the lecture, guys. So, if you open section 2, part D, subpart 1, you will find stress tables, guys. So, you will find different stress tables like table 1A, 2A, table U, table Y1. Like this, you will find different stress tables. It's around 13 stress tables, 12 to 13 stress tables are there. So, if you have a code book, just open and see. Okay, so did you think about why are there code given these multiple tables instead of one comprehensive table? Did you ever think this point, guys? So why the code given these many tables instead of one comprehensive table? So think before listening the answer, guys. So the reason behind this question is we have several categories of materials, right? Like ferrous, non-ferrous, bolting materials. So according to these categories, these tables are classified. Okay, and we have one more point, like we have several design codes in ASME BPVC, like section 1 for power boilers, section 3 for nuclear, and section 8 division 1 for general pressure vessel applications, and section 8 division 2 and division 3 for high pressure vessels. Okay, each code has its unique factor of safety, which means that we require different allowable stresses for different codes. So this leads to the need for multiple tables instead of one comprehensive table, guys. I hope now you understand why code given these many tables instead of one comprehensive table. According to these categories, let's derive the tables, guys. If you find table 1A, 2A, 5A, 6A, the A refers to ferrous materials. So the data you will find in these tables is purely about ferrous materials only. And if you see the data you find in 1B, 2B, 5B, 6B, that is about non-ferrous materials only. The B refers to non-ferrous, A refers to ferrous materials, guys. And table 3 and 4 is for bolting materials. I hope you understand this concept. One A refers to ferrous materials, B refers to non-ferrous materials, and table 3 and 4 for bolting materials. I hope you understand. We have table U and table Y1. So what the information you will get in this table U and Y1 means tensile and yield strength values. Tensile and yield strength values at different temperatures, guys. Not at one temperature. You will get this tensile and yield strength values at different temperatures. I hope you get some idea on these tables now. So let's derive these tables according to this several design codes, guys. So if you open subpart 1, you will find stress tables. This table 1A is applicable for these sections only. That is for section 1. Section 8 we have sorry. In section 3 we have different divisions. In that division 1 also we have different classes like class 1, class 2 and 3 like that. And section 8 division 1 and section 12. So your table 1A is applicable for ferrous materials for these type of design codes only. And you have table 1B is for non-ferrous materials and these code books, guys. For these codes only, this table 1A and 1B is applicable for. No need to remember everything, guys. You no need to remember this. So if you are working in section 8 division 1, you will remember that is table 1A and table 1B itself. So don't need to remember all this stuff. So it is like good to know. So it is good to know category. So and table 2A. So in table 2A is applicable for these categories and table 2B is applicable for these categories. A means ferrous, B means non-ferrous. So what does it mean class 1 and here division 2 class 1, division 2 class 1 guys? So division 2 class 1 applicable to part 4, that is design by rule, that is about formulas only. So class 1 deals with formulas, design by rule. So I hope you understand. And the next one is table 3 and table 4. Table 3 and 4 is for bolting materials and applicable for these sections. Okay. And we have table 5A and 5B. It is applicable for division to class 2. This class 2 is FEA analysis, guys, finite element analysis. So we will find the thickness by finite element analysis for ferrous and non-ferrous materials. And next one we have 6A, 6B, 6C, 6D. It is for section 4 only. A means ferrous, B means non-ferrous, C means lined water heater materials, and D means unlined water heater materials. So if you work in this application, you will go to this table 6C and 6D. Next one, you have table U and table Y1. I already informed you. Table U refers to tensile strength values and table Y1 gives you yield strength values at different temperatures for both materials, ferrous and non-ferrous materials. So let's see what is exactly in these tables, guys. For example, if you take table 1A, what you will find in the table? You will find chemical composition. So chemical composition means uh, how much carbon percentage. That that all the stuff you will not find in this. You will find only what type of material, either carbon steel or nickel alloys. So that will you will find in this chemical composition. Okay. And next one, minimum tensile and minimum yield strength values. So this minimum tensile and minimum yield strength values at 100 degrees Fahrenheit you will find in this table for different materials, and you will find maximum temperature limits for section 1. What is the maximum temperature limit for this table, and section 8 division 1, what is the temperature limit for this table? So that all the stuffs you will find in table 1A. And external pressure charts, I already told you in last lecture. So about in session 3, I mean in subpart 3 you will find these external pressure charts, guys. So for which material, which external pressure chart is suitable, so that you find in this table 1A. And you also get maximum allowable stress values at different temperatures. Hope you have one idea about what you find in each table. So this information only you will find in each and every table. So if you want, you can check in code book, guys. So let's see. Here I provided you one example like SA240 type 304. If you open table 1A, you will found nominal composition, that is chemical composition, like how much like carbon steel or whatever the steel, and you will find product form, that is plate, tube, or seamless pipe, or a welded pipe. All the stuff you will find, and spec number into for like we have SA204, SA304, like that, SA240, like this spec numbers are there, you will find here. And the type and the grade, either SS304. So what type of grade, like if you see SA516 spec number has different grades like 65, 70, 75, like this, we have grades, right? So the grades will find here. And you will find, so size or thickness, so how much thickness it is available, and also external pressure charts also available. Okay, you can see here external pressure charts, and for which code, at what temperature it is applicable. If you see, section 1 is applicable for 1500 degrees Celsius for fifth fifth material. So you can see here 18 chromium nickel material has 75 minimum tensile strength and 30 minimum yield strength. It is applicable for 1500 degrees Celsius for section 1. If you take section 8 division 1, so it is applicable for 1500 degrees Fahrenheit. So everything is in Fahrenheit only, guys. And you will find external pressure chart like HA1. So like this you will find. And you will find some general information in notes also. You can check that one. And next one, you will find maximum allowable stress values for different temperatures. I already told you for different temperatures, you will find different stress values. If you see, so for material 5, you have 20 KSI value at 100 degrees Celsius and 15 KSI at 300 degrees Celsius. Okay. So if you want intermediate like 550 degrees Celsius, you need to do interpolation. I hope you are getting my point. So like this, I'm ending this session, guys. So this is the all the stuff you find in tables. I mean subpart one tables. So I hope you understand. You enjoyed this session. Please subscribe my channel for more interesting videos.